Okay, here we are back in my basement again. You can't see me because that eats up a lot of bandwidth. Um, I am going to start today with just a little bit of a reminder. Stay home, stay healthy, okay? We now have a confirmed, actually not confirmed, presumptive case. There was a positive test um, for a person. My understanding is that that person was an inmate at Kinross Correctional Facility, which means that the coronavirus came in from the outside, which means it's somebody doing deliveries or a visitor or a um, uh, staff at the prison. Coronavirus is here. Stay home. Now, what I'm going to do today is we're going to shift to using classes. And so in today's lecture, and I'm going to bring up our PowerPoints here, I'm going to introduce a lot of new ideas. And these new ideas are going to come fast and furious, but they're ideas that we're going to use for the rest of this course and pretty much all of the next course. And so you need to pay attention. When necessary, you need to go back and listen to pieces of this or watch pieces of this again. I'm going to do a fair amount of programming starting today. Your first programming assignment that uses classes, program 6, is just going to be a re-implementation of a stack using classes instead of, well, that's not quite right. Using classes to encapsulate the struct and the functions that we wrote for programming assignment 5. Okay. A little bit of administrivia. Test 2 grades should be posted on Moodle later today. And midterm grades, I am hoping I can get out the door by tomorrow. The last day to drop this class and all of your classes, the last day to withdraw, I should say, is Friday. Bear that in mind. And we will be, I believe it's the last day is Friday. We've slipped some of the deadlines. You've got to read your email. You just have to read your email. Okay. So now I'm going to introduce some new ideas. You're going to want to pause and repeat and make sure that you're understanding and catching what I'm doing. And so the first thing we're going to do is alter our original stack.h to create a stack class. That stack.h will become our specification. So just as a reminder, okay, every class that we create has to have a constructor and a destructor. I also require every class that we create to have separate specification and implementation files. So the first thing I'm going to do is work on the specification, that's the stack.h, and then I'm going to create a stack.cpp file, and that will have the implementation. Okay. Now, the stack class will use the exact same struct, stack node that we used in program 5 and that we used in, I think it was example program 5. I'm starting to lose track of the number of example programs, but I've got them all stored in the file or in a folder for each one of these lectures. And so this is lecture 5. So this is a new idea. Okay. So we are taking the struct for the stack and placing it as private data inside the class. This is not the way Savage does it in our textbook. He actually has the struct outside the class, and I don't agree with that. So I prefer to put that struct into private so that we information hide. We're hiding the information about how this stack is constructed. What we will now have is two .cpp files to compile into one executable. And that'll be ex6.cpp, which is example program 6, and stack.cpp, which is the implementation file for our class. Now, this is a new idea, even though you saw me do this with the sensor network node example. You compile both at the same time, okay? The new stack.h, I'm gonna share the editor window here in just a second. Now be careful, I'm programming on the fly, and I'm programming while describing what I'm doing. I'm not commenting the code, okay? The comments essentially are what I'm speaking. And this is so that you can see how I'm building, compiling, and testing along the way. And quite frankly, I'm gonna make mistakes. I'm gonna get compile errors. I'm gonna have to change and fix things. This is all a normal part of programming. Sometimes as faculty, we have a tendency to bring everything nice and polished to class. And this is something I really don't do. You've seen me program in class. But I was starting down that path with the last couple of lectures. And I realized that this isn't realistic. It gives you, the student, an unrealistic expectation that your program's gonna work first time. And that's not the case. Your programs will never work the first time, and they won't actually be correct until you've tested extensively. And so that's what I'm gonna do here. Now, for now, all our class is gonna hold is, again, that single character. And that single character is going to be inside the struct. So off we go. Now I've got to go back and do a new share. Here's my new shared window. I think I've got everything in here. I'm going to move ex4.cpp to ex6.cpp. Okay. And I've got stack.h in here as well. So I'm going to start with stack.h. No C indent. I'll make things a little easier on us. Okay. I include IOStream. I'm using namespace standard. But here's that struct that we had for our first example of a stack. And this struct is exactly the same as the one that you used in program 5, provided you've turned in program 5. What I'm going to do now is create a class. So that starts with the class keyword, and then it has the name of the class, which the convention is to capitalize the names of classes. So this is class struct, or stack, excuse me. And then it's going to have inside of it a public section. These are the things that people outside can see. And it's also going to have a private section. And this is the stuff that we want to hide from people outside, okay? Into that private section, I'm going to insert the struct. So I'm just gonna re-indent all this stuff so that it makes sense, okay? Now, I don't remember whether that semicolon exists there or not. Like I said before, I'm programming on the fly. You're going to have to follow what I do, and I'm just gonna call this out right now. I'm gonna delete it because something in my memory says you don't need that. And then I'm gonna close off the stack, and I will put a semicolon at the end of the class definition, because I'm pretty sure you do need that one, okay? Now, what goes in here? Well, for a stack class, we're gonna suck in those pieces of programming that were either in main or defined outside of main, but still within main scope. That includes our functions, and that includes our head pointer, okay? So right here, in the private data, because again, we don't want anybody to see that private data, I'm going to declare a stack node star head, okay? Now I'm not going to initialize that here because initialization really is going to happen in the constructor, okay? Remember, when I define something to be of type class, that constructor is going to run, and that constructor will set head equal to null, okay? Here in public, indeed, I do need that constructor. So our constructor is the same name as the class, doesn't take any parameters. And a destructor, which is tilde and then the name of the class. And again, no parameters. We need a push. And remember, our push was void push. But this is going to be a bit different, just slightly. And it's only at the parameters. Because this function has become a member function, or what we call a method inside the class, we do not need to pass in head. And in fact, the end user of our class, of our stack, shouldn't even know that head exists. Head is defined way down here, okay, right in here, as a piece of private data. So once we're executing this push, we have access to head because it's in the same container. So all we need to do is push the data, and that's a single character, okay? So that's the prototype for our push. Our pop is going to return a single character, and it doesn't need anything to be passed into it, okay? We also need an isEmpty, which is going to be a Boolean, isEmpty. And we have a void print stack, which actually is just simply a way to debug what's going on. Most of the time, we wouldn't care about the print stack. And in fact, for most classes, what we'll see in about a week, maybe a little less, is that we would overload the stream insertion operator. And we'll get to operator overloading probably in tomorrow's lecture. It's going to be another new idea. So at this point, the new ideas just keep stacking. And you're going to want to really take notes, write stuff down, maybe rewrite your notes, rewatch parts of the lecture, what I'm doing right now, so that you understand what's going on. Okay? So those are our four member functions, or our four methods, okay? We have everything we need now to build this stack class. That's the specification, okay? So I'm going to get out of here, and now I'm going to go back to our PowerPoint slides. So here's our PowerPoint slides. Okay. Now, stack.cpp. The biggest thing here is we have to be careful of our scoping operators. We got to make sure that those scoping operators are there. Most of the time, this is where problems come in. with compilation, with, you know, having the functions or the member functions, the methods defined in the right place. So this stack.cpp is going to be a completely new file, but it's going to include a lot of code that we've already seen and or written before, okay? So stop that share, go back over. Grab our window where we're editing things. So right here, I'm going to VI a new file called stack.cpp, okay? Now, this is something I do when I'm programming, and instead of creating stack.cpp as a clean slate, and this might be confusing, so I'm debating whether or not I should do it. But I'm just going to copy stack.h into stack.cpp. Now if I go into stack.cpp, the first thing I'm going to do, whoa, what happened there? Oh, if you see, I got a mistype right there. So I need to rename that stack.cpp as stack.cpp. There we go. Now, if I go in there, I've got the specification. I'm not going to need the class piece or public or private or the private data or the end of that definition. Sorry for the binging, but this is the way I program. And VI bings at me a lot. So here we go. Now I've gotten rid of all of that stuff from the specification. But the reason I did this is because it reminds me all of the functions I have to write, okay? So there's 4 stack-specific functions, member functions, and then there's the constructor and the destructor. Not only that, but up here, I'll need to include stack.h. Okay? So remember, this is our .cpp file. This is where the code goes. The .h file, that's just where the prototypes and the specification goes. Okay? So first thing I've got to write is stack. And I've got to set no C indent again. Okay, because I don't like the way that Vim decides to indent on me. Okay, we're going to open up the constructor. And really the only thing I need to do is set head equal to null in here. And then close that off. Okay. I could go up here and execute a return. Probably just to keep things consistent, I will. So there's the return. Okay. Now the destructor. The destructor is going to need to walk through the stack if there's any allocated pieces of memory, and it's going to have to return those to free memory. Otherwise, we've induced a memory leak, and that memory leak is going to bite us. It's going to hurt us. It's going to make our program, if somebody uses this data structure that we're providing, it'll make their program crash. The sneaky thing about memory leaks is that they don't cause your program to crash right away. It's only if you use your program for a long time, if you keep it running for a long time, then it slowly eats through the memory until it can't get any more memory and then it crashes. So that's what we're looking at right here. I'm going to hold off on writing the destructor for just a bit. I really want to write pop and is empty before I write the destructor, and you'll see why. Now here's our push. Remember, our push doesn't have any special cases. We don't have to check to see if head is null or not, okay? And in fact, what I'm going to do, and you can't see me do this because I haven't shared this, but what I'm going to do is I'm going to go back to that old code that we had. Let me see. That is not what I was looking for. Yeah, that's what I'm looking for. So I'm actually off screen right now, looking at that example that I created a couple of lectures ago. And so x6.cpp. So all I'm doing this for is to make sure that I give you exactly the same code as I wrote in that example, so that you can, so that push is essentially the same. Now, remember, I've deleted the stack head parameter right here because this doesn't require stack head. Remember I said be careful about those scoping operators? I need that scoping operator. Stack head isn't required for this function because this function now is inside the class. It has access to head, which is exactly what we wanted. I'm going to declare a local variable called hold. Okay. This is just like what we did before. Notice that I'm using stack node, but since we're inside the class, always think about these functions as existing inside of that box. Since we're inside the class already, I have access to that definition for stack node, okay? And then the code is very much like what I wrote before, except that hold equals stack head is no longer the code that I want to write. I just want to say code equals head. Okay. And then head, instead of stack head, head equals new stack node. Okay. Head arrow next is equal to hold. Okay. So what happened here is hold might have a stack. Head could be pointing to, when we enter this function, head could be pointing to an already existing stack with some nodes in it. So hold saves that address. Head, we allocate new space, so that's just a new stack node with garbage in it. Now we're setting heads next, so the new garbage memory, we're setting its next to point to hold, which points to the old, the data that was there in the stack already, the old head. And then we need to copy in our new data into there. So head arrow data is equal to the parameter that we passed in, the data, okay? And that's our push. Pretty simple, pretty straightforward. Barely changed from what we wrote in our example and what we wrote in program 5. The only difference is now that we have hidden the pointer head. The end user of our stack does not see head. It is now encapsulated. So to use object-oriented programming terms, this is encapsulated. Nobody can see it except us, who actually needs to see it. Okay, we're going to do the same thing with pop. Remember pop before took a stack node pointer called stack head. It was a reference parameter, which was a new idea. Now we don't have to, because we have access to head directly from inside the class. And so head can be altered in here as well. So I'm going to define that local variable just like we did before, char the data. I'm going to give us a little bit of space here. And in fact, this one's going to be long enough that I'm actually going to write the return and the closing brace, and then I'll go back up here and fill it in. Okay, so there's char the data. And I also had a stack node temp. So stack node star temp, and this is to hold the memory that's pointed to at the top of the stack so that we can delete it later. Okay, and in fact, I could initialize this right now to head, and that will work. First thing we're going to do is check to see if head, not stack head now, I've changed the name because I'm using the name that of the private data inside the class. So if that is equal to null, then I'm going to return char okay. So that return was pretty weird, and you should have gotten a little bit confused the first time you saw it. That return is actually saying I don't have a character to return, so I'm going to return -1. So as a signed char, these chars are signed. I could print out an error message at this point, but inside of functions, don't see out crap. I said that rather forcefully, maybe a little angrily, okay? You're starting to get into the habit. I'm looking through your code. I'm looking through your test question answers, and you keep taking things that should be returned as the return value of the function, and you're printing them out inside the function. When I call cosine in the math library, it does not print out the cosine of the angle I passed in. It simply returns it to me, and then I decide whether I want it printed out or not. That's the philosophy that we need to take from here on. Just because you're writing a function and you might want to see what's in that function, don't see out it except for debugging. And once you're done with your debugging, remove all those see outs. You don't want those print statements in there, okay? So now I close that off. That's my error case. The rest of the code is actually what needs to happen in order to return what the top of the stack was. So the data equals head arrow data. That used to be stack head, now it's head. Because we're inside the container, we have direct access to that private data member. Temp is equal to head. Oh, wait, I did that already. I did that up here, right up here. So I don't have to do that again. So that line of code from our prior example in our program 5 is gone. And then we say head is equal to head arrow next. So this just walks the pointer down one node in the stack, the pointer head. And then I delete temp, which returns temp to free memory. That's it. We're done. Boom. Now, is empty. That's all that isEmpty is. Head equals null will return true if head is null. And that means that isEmpty will return true, which means that the stack is empty. If head contains an address of a node, then head equals null will be false, and the return will return false for isEmpty, i.e. the stack is not empty. There's a simplicity to this. And in fact, let's go back up here on our if statement. See how I have that same check right here? I really shouldn't do that. I should invoke the member function isEmpty. So now I'm asking the same question. If isEmpty, then I return. And now finally print stack. I'm going to need a temporary pointer in print stack because I'm going to have to walk that temporary pointer down the stack, printing as we go. I'm going to start that out at head. Let me scroll up a bit so you can see what's going on here. Now I'm going to see out. Okay, so I print out a header. Then I like to put a line under my header like that. And now I'm going to start a while loop. I'm deciding on whether I want a blank line here or not. I guess I do. While temp does not equal null. We're done with head. Do not use head here. If you use head, you'll destroy your own stack. Temp, we use temp so that we don't do anything bad, okay? And we're just going to print out data. We're not going to alter anything. So while temp is not null, if the stack is empty, we don't print anything. If it isn't empty, then this while loop is going to run. And all we have to do is see out. I'm going to put in 4 spaces like that. And then I'm going to do temp arrow data. So that is temp is pointing, it's going to successively walk through the stack, starting at head, the node at head, and walk through the stack, printing as we go. And then I need an ENDL because I want one piece of the stack at a time on each line. Okay, when we're done with that, then I'm going to do a cout done period \n \n to give it a blank line there, and then return. Oh, I see some mistakes up above. I'm missing the scoping operator here. I'm missing the scoping operator here. I even put it in the PowerPoint slides and I'm still missing them. And the scoping operator there. Now remember when I said we'd come back to stack the destructor and do that later? Now that I've written isEmpty and pop, I can use those in the destructor. I know that pop returns things to free memory. So I'm going to use that. And in fact, the destructor just became incredibly simple. It's going to run in a while loop. because as long as there's stuff in the stack, as long as the stack isn't empty, I want the while loop to run. As long as this stack is not empty, I want the while loop to run. Oops, I didn't shift my one there. Shift it. While not is empty. Pop. That's it. I don't care what's coming back from the pop, the character that pop is returning, because I'm not going to print it out. This is when I deallocate, when the program deallocates a stack class. All it has to do is return the memory to free memory, and pop does that for me. I don't care what's on the stack. Obviously, if I cared, I would have emptied it before we deallocated the class variable or the class object. So that's it. That is absolutely it. And that will return all of our memory to free memory. Now, I'm going to get out of this, and I'm going to look at example6.cpp. Okay. So this was actually, this is my solution to program 5. If you're paying attention, you would have just seen the solution to program 5. All these functions that are stack specific are now in the stack class, so we can delete those. I can delete push, I can delete pop, I can delete isEmpty, I can delete print stack, okay? String length, max string length is still particular to the application program, and I'm going to keep it right there. I no longer have a stack node, so I get rid of those. What I do want to do here is to, let's see. Is I want to define a variable of type stack. So stack, that's the class name, is the type, and my selfie stack is the variable. Okay. I've got a string that I'm going to read into, and I've got an int I. Oh wait, while not is empty head, see out pop stack. Ah, okay. Funny how this works. So what is the message in the selfie? By now you've figured out that cin stops on white space, so you couldn't produce anything more than a single word in your input. There's a way to get cin to not do that, but we're just sticking with what program 5 was right now, okay? So what is the message in the selfie? Cin that string. Then for I equals 0, I less than the length of the string I++, I'm just going to walk down the string, pushing each. I no longer have to use head in the push because head is now inside the class. In fact, I have to do my selfie stack dot push. See how that works? I've got an object that's of type stack. It's a container. I use the dot command to get inside the container. Once I'm inside, or once I've opened the container, I can't see the private stuff. All I can see is the public stuff. And so the stuff in public are the constructor, the destructor, push, pop, isEmpty, and print stack. So I have access to all of those, but I have to go through the container or through the object to get there. And so I've got to do my selfie stack dot push. And in fact, this name is really starting to bother me. I regret it already, so I'm going to take out the selfie part, and I'm going to take out AC, so it's really short. And so my STK, that's a stack. My STK push in string, print stack. Well, wait, I can't invoke print stack directly. I have to go through the object to get there. So that's my stack dot print stack. While not, and again, here's the scoping operators that I warned you about, or not scoping operators, but here's the container that I warned you about just about 10 seconds ago. I can't access isEmpty directly, and head no longer exists. So I need to get rid of head in the print stack, and I need to get rid of head in the isEmpty. Remember, I don't get access to head. Head is hidden from me. Head is encapsulated. Head is protected. Same thing with pop. Get rid of head. And we also need to be inside the container to get access to pop. And that should be it. Notice how the code actually got a lot simpler. As the application programmer, if you think about it, that's what you're doing right now, is you're writing the application. The application programmer now just uses a stack. It doesn't care about all the stuff that goes on inside of that stack. That was for the developer of the abstract data type. Now we're serving both roles in this class. We develop the abstract data type and we're the application programmer. So in this case, we've done both. It looks like it might compile, and so I'm going to try it. So G++, I'm going to call this, so I'm going to use the -O, and I'm going to call this ex6, and I'm going to compile ex6.cpp and stack.cpp. Okay? If I have done everything correctly, then there should be no compile errors. Oh, look, I haven't done everything correctly. Expected semicolon at the end of declaration. So in stack.h, line 22. So stack.h, line 22. Remember I said I didn't think it needed the semicolon after that struct declaration? Turns out it did. So that's one of our errors. I noticed another error in here, and it was something about a, something about a, let's see, stack node star head with no type. That came from that lacking semicolon. ex6, line 26, so via ex6.cpp, line 26, and I deleted a right parent. I like to do clears when I'm doing compiles, and that way I don't get confused about the errors that I got last time versus the errors that I get this time. So I'm going to recompile. Whoa! Declaration of tilde stack as non-member. That's in stack.cpp. And guess who forgot a scoping operator? The person who's warned you multiple times, be careful of your scoping operators. That's it. Clear. Compile. Woo! Now I'll run the what on Colossus would be a.out. On my local machine here is a.exe. Oh, I renamed the executable. That's right. I did the -o on the G++ right up here. And so the executable's name is actually ex6. Now I've got to wait for stupid Avast to decide that this program isn't a virus. There we go. What's the message in the selfie? Boy, this is really hard for me to do because I've got to try and put things in backwards. So let's see if that works. Oh, I want a capital S there. Whoa! So I got stuck on S. I'm going to scroll back up and see if it's S all the way down. Yeah. So something happened here. I'm going to go back to my code, ex6.cpp. I know that I've got a bunch of S's. I know that S was the last thing added to the stack, so therefore should have been the first thing removed from the stack. Well, and so this is potentially in print stack. So I've got my for loop, it pushed everything on. How do I know that? Because I see S. S was the last thing in string. So I should check print stack first. So I'm going to go down here. I'm going to look at print stack. Oh, I see it already. Temp is equal to head and never moves. The while loop didn't update temp. So temp equals temp arrow next. It's got to walk down. And as I look over at my solution for program 5, sure enough, temp equals temp arrow next is right there. I just didn't copy it. So I'm assuming that that fixes my error. I'm going to recompile. I misspelled temp. Recompile. Okay. And now run the program and wait for Avast to clean stuff up. What is the message in the selfie? Hopefully. There we go. The stack contents, we pushed everything on correctly. I printed them out. And then my while loop in main went through and printed each pop. And that's it. Our constructor worked, our destructor, I assume, worked. It's really hard to tell if destructors work correctly or not. My push and my pop appear to have worked. Looks like everything worked. Now, given that I was working from code that I knew worked already, that's not a surprise. So that is pretty much our 50 minutes for the day. Tomorrow, we'll do that abstraction, getting rid of the application data so that it's not in our ADT class. And that means that we're done for the day. This will be posted on Moodle in about 5 minutes, maybe a little less or a little more because it has to convert. And I'll send out a message as soon as it's done. Goodbye for now.